When we talk about modeling credit risk, we are mainly trying to understand how much money a bank can lose if borrowers fail to repay their loans. But we are not just interested in average losses. What really matters is the possibility of extreme losses, especially during bad economic times. This is why we use something called a credit loss distribution. It shows all possible loss outcomes, from 0% loss to 100% loss. Most of the time, losses are small because borrowers usually repay. But in rare situations, losses can become very large. These rare but severe losses appear in the tail of the distribution, and that tail is what banks care about the most. To model this properly, banks often use something called a beta distribution. The reason is simple. Credit losses are measured between 0 and 100%, and the beta distribution also works between 0 and 1. It is very flexible. Depending on two shape parameters called alpha and beta, the distribution can be symmetric or skewed. If both parameters are equal, the distribution is symmetric, meaning losses are evenly spread around the average. If they are different, the distribution becomes skewed, meaning losses are more concentrated on one side. The average of this distribution represents expected loss, while the variability around it represents unexpected loss. However, since extreme losses are rare, banks usually combine the beta distribution with Monte Carlo simulation. This simulation runs thousands of random scenarios to estimate what could happen in very bad situations and helps measure tail risk more accurately. Now, even though we have these models, measuring credit risk is not perfect and comes with challenges. First, many models assume that assets like loans can be sold easily in the market. In reality, loans are often illiquid, especially during a crisis. When markets are stressed, selling assets becomes difficult and losses can be much higher than expected. Second, most credit risk models use a 1-year time horizon, but borrower quality does not change in just 1 year. It evolves over several years depending on economic conditions. Ideally, models should capture long-term changes, but doing that accurately is very difficult. Third, in practice, credit risk is measured separately from market risk and operational risk. Different departments handle them. However, in real life, all these risks are connected. During an economic downturn, borrowers may default, market prices may fall, and operational problems may increase at the same time. Because models often treat these risks separately, they may underestimate total risk. So overall, modeling credit risk involves estimating the full range of possible losses using flexible tools like the beta distribution and Monte Carlo simulation, with special focus on extreme losses in the tail. But we must remember that real-world complexities, liquidity problems, longer-term borrower changes, and interconnected risks make credit risk measurement challenging.